Let's talk about the domain and the range of a function. The domain equals all possible x or input values of the function, and the range equals all possible y or output values of the function. A lot of times in many of the functions you're going to see, the domain and the range are both simply just all real numbers. The function extends horizontally as negative as possible forever and positively in the x direction forever, and the y values will also decrease infinitely and increase infinitely. But there are some functions in which certain x or y values are not valid and the function is not valid for those values. So let's take a look at a couple of examples. Our first function, f of x equals x cubed. So the input here is x, the function is cubing the x value, and the output, or y values, are also known as f of x, or the function of x. Now, if we look at the graph of this function, which has been graphed for us, you can kind of tell if we're looking at what x values are valid for this function, you can kind of see that this function, if we were to extend this graph horizontally forever and ever, it doesn't look like there are any x values where this graph would not exist. It would go on forever in the positive x direction and in the negative x direction. So our domain in this case is all real numbers. What about our range? What about the y values? Again, as you can kind of see and guess from this graph, if we were to extend the graph to the top and bottom infinitely in both directions, we would probably see this getting bigger and bigger and bigger as the graph goes up and more negative as the graph goes down infinitely. And you can think about that too. If you were to keep increasing, the higher the x's get in here, the larger and larger your output values are going to become, or the more and more negative that the x's get, the smaller and smaller your output values are going to become. So our range in this case is also all real numbers. That just means this function is going to continue on in all four directions until infinity as you increase or decrease the x values. Let's take a look at another example. Okay, if you examine the x values in the graph of this function, and the function is f of x equals 3 all over 2 minus x, you can see that the graph seems to approach x equals 2 from these directions, but it kind of looks like it never quite gets there. And if you look at our function over here, if x were to equal 2, the denominator would equal 0, and we know that that is undefined. There is no such thing. You cannot divide a number by 0. There is no such value. So this function, you cannot have an input value of x equals 2. So the domain for this function is actually all real numbers except for 2. So any other number works in this function except for the number 2. What about the range? What y values are valid for this function? So if you, again, take a look at the function, it seems to, on this side, go up and up forever, but as it comes down, it doesn't look like it's going to cross this x-axis over here. And on this end, it seems to go negative and negative forever, but then again, it seems to be approaching y equals 0, or the x-axis, but never actually crossing it. And if you think about our actual function up here, you can see you're never going to have an output value of 0 because 3 will always be divided by some number, and you can never make this function 0. You definitely can't have 0 on the denominator. That wouldn't make this function 0. That just makes it undefined. So the range is all real numbers except for 0. That means that Y values can extend for any number and will reach any number at some point in this function except for the number 0.